Good day everyone. My name is Stephanie Nicolas, taking the course of Bachelor of Science in Computer Science, and in this video, I will discuss about Lamport'S mutual exclusion algorithm. Lamport'S distributed mutual exclusion algorithm is a permission-based algorithm proposed by Lamport as an illustration of his synchronization scheme of distributed systems. In permission-based timestamp is used to order critical section requests and to resolve any conflict between requests. In Lamport'S algorithm, critical section requests are executed in the increasing order of timestamps, i.e., a request with smaller timestamps will be given permission to execute critical section first than a request with a larger timestamp. Three types of messages, request, reply, and release, are used, and communication channels are assumed to follow FIFO order. A site sends a request message to all other sites to get their permission to enter critical section. A site sends a reply message to requesting site to give its permission to enter the critical section. A site sends a release message to all other sites upon exiting the critical section. Every site SI keeps a queue to store critical section request order by their timestamps. Request queue denotes the queue of site SI. A timestamp is given to each critical section request using Lamport'S logical clock. Timestamp is used to determine priority of critical section requests. Smaller timestamp get high priority over larger timestamp. The execution of critical section request is always in the order of their timestamp. Algorithm. To enter critical section, when a site SI wants to enter the critical section, it sends a request message, request TSI, to all other sites and place the request on request queue. Here, TSI denotes the timestamp of site SI. When a site SJ receives the request message, request TSI from site SI returns a timestamp reply message to site SI and places the request of site SI on request QJ. Algorithm. To execute the critical section, a site SI can enter the critical section if it has received the message with timestamp larger than TSI-I from all other sites and its own request is at the top of request queue. To release the critical section, when a site SI exits the critical section, it removes its own request from the top of its request queue and sends a timestamp release message to all other sites. When a site SJ receives the timestamp release message from site SI, it removes the request of SI from its request queue. Lamport'S algorithm requires invocation of 3N1 messages per critical section execution. These 3N1 messages involves N1 request messages, N1 reply messages, and N1 release messages. Drawbacks of Lamport'S algorithm. Unreliable approach. Failure of any one of the processes will halt the progress of entire system. High message complexity. Algorithm requires 3N1 per critical section invocation. Performance. Synchronization delay is equal to maximum message transmission time. It requires 3N1 messages per CS execution. Algorithm can be optimized to 2N1 messages by omitting the reply message in some situations. So, in my understanding of the process of the Lamport'S mutual exclusion algorithm, based on the picture works by first passing the message from each A, B, and C, and after that, based on the recognized timestamps, the first message will be recognized and will first enter the critical section if approved by A and C, and as we can see in the picture, the letter B first entered the critical section, which means it was given permission by A and C because it was the first message based on the timestamp, and after the resources in message B in critical section is released, then what happens is letter A enters the critical section and message it's passing. So now letter B exits the critical section and A will now be in critical section.
And that's all for my topic. Thank you and thank you for watching.